This is question 22 in exercise 20.2 in Project Maths 1. We have to solve the following pair of simultaneous equations, and the book has given us a nice hint to start with, which is write both equations in the form ax plus by is equal to k before attempting to solve. So our equation 1 starting off is 3x plus 2y minus 7, and our equation 2 is x minus 3y plus 5. So if we rearrange these, we're going to get, for equation 1, 3x plus 2y, and we're going to move our minus 7 over the equals, it's going to become just plus 7. And for our equation 2, we're going to get x minus 3y is equal to, and we bring our 5 over, it becomes minus 5. Now this sum can be done by either matching the x's or the y's, depending upon which you find easier. Because there's already a different sign in front of the y's, we'll go with that way first. But we'll have a look at it again in a moment where we match the x's up. So to match the y's up, what we're going to do is we're going to multiply equation 1 by 3 and equation 2 by 2. And we'll see what happens then. So we're going to get 9x plus 6y equals 21, and then for equation 2 we're going to get 2x minus 6y equals minus 10. Okay, and you can see from this that after making that change to both the equations, we've now got the same number but different signs in front of both of our y's, which means if we add everything down we can form an equation in just one variable. So 9x plus 2x is 11x, 6y minus 6y is 0, and 21 minus 10 is 11. So we have an equation 11x equals 11, which means that x is going to be equal to 11 over 11, so x is equal to 1. And with x equal 1, we can now put that back into one of our equations from above to get our value for y. So let's go with equation 2. So our equation 2 was x minus 3y plus 5 equals 0, and we know that x equals 1. Well, that means that 1 minus 3y plus 5 is equal to 0. So minus 3y plus 6 is equal to 0. So if we move our plus 6 over, we're going to get minus 3y is equal to minus 6. So y is going to be equal to minus 6 divided by minus 3. So y is equal to 2. Okay, so that is a perfectly valid solution, and that will be the end of the sum if you want it to be. The other approach we can go with, if we want to, is instead of getting our y's to match the way we did, is we try to get our x's to match. So we start off with the same equations as before. We're going to rearrange them the same way as we did before to get them written the right way around. So our equation 1 is still 3x plus 2y equals 7, and our equation 2 is still x minus 3y equals minus 5. And this time we're going to see what happens when we try to get the coefficients of the x's to match. So what we're going to do is we're going to do absolutely nothing to our equation 1. It's going to stay as is, as 3x plus 2y equals 7. But to our equation 2, we're going to multiply that by minus 3. So we will get minus 3x plus 9y is equal to 15, like that. We draw a line. I'm just going to add everything down. 3x minus 3x is 0, 2y plus 9y is 11y, and 7 plus 15 is 22. So we have 11y equals 22, which means y is equal to 22 over 11. So y is equal to 2. And in order to get our value for x, we're going to go back to our equation 2, which was x minus 3y equals minus 5. Only this time we have a value for y, and that's 2. So it's going to be x minus 3 times 2 is equal to minus 5. So it's going to be x minus 6 equals minus 5. So x is equal to 6 minus 5, because we bring our minus 6 over and it becomes a plus 6. So x is equal to 1, which is exactly the solution we got above. So either way is a perfectly acceptable approach to this sum. And that is that.